Students, we are discussing the coaxial cable, and what we looked at was the structure of the coax cable and the different standards of the coax cable alongside a few applications as well. Students, we'll go to the next slide and we'll talk about the coaxial cable further in terms of what connectors can we use with this coax cable, and then we'll finish the discussion of coax cable with the discussion of the performance and the comparison of this performance with the twisted pair cable. Students, in this particular case, we have got the case of coax. By the way, we have got the Bnc connectors. As you can see, we have got the Bnc connectors is a bayonet connector, and three popular types of these connectors are shown in this slide. The first one is, which is the Bnc connector. It is used to connect the end of the cable to a device. For example, if you've got a coaxial cable that's coming to your residential premises, your house, you'll see that this coaxial is connected to your TV set using this bayonet or Bnc connector. So the second type is Bnc-T or the Bnc-T connector. It is mostly used in Ethernet networks. We'll talk about that in the upcoming discussions. And it is used to branch out a connection to a computer or other devices. So if you've got an electrical signal that's coming in, you actually use a T connector to branch out that electrical signal or that connection to multiple devices in addition to the one that you have already connected it with. Students, then you've got the Bnc Terminator. And normally if you've got a coax, which is the end of the wire, you've got multiple T's and there's a coax cable that's just hanging out there without anything connected to it, then we terminate that particular coax cable to avoid the loss of signal by using a Bnc connector. It's a 50-watt connector which just covers the end of that coax cable, and it's got a ground wire in it as well. Students, बात करेंगे कुछ coaxial cable की performance की. As you can see, we finished our discussion of twisted pair cable performance with a frequency range of a highest frequency range of 1000 kilohertz. Students, we are talking megahertz out here, and as you can see, we are somewhere between 10 megahertz and 100 megahertz, and we have got the different gauges in this particular case of the coax cable. These are the three standards that we spoke about, and in this particular case, you can see that the attenuation is much higher. Our attenuation for twisted pair was maxed out at 20 dB per kilometer. In the case of coax, it's capable of carrying higher frequencies, but our attenuation levels are higher as well, and they are pretty exponential. So, for example, you can see that for this red cable, whatever RG standard that is, you can see that at a particular level of frequency, we have got an attenuation of approximately 5 dB per kilometer. But going from this level to approximately 10 megahertz, as you go up in the frequency or the frequency of the carried electrical signal, it increases, our attenuation increases rapidly as well. So our result is that coaxial cable is better in performance at higher frequencies than twisted pair, but you have to have a balance between the frequencies that you are carrying and the attenuation that you are experiencing. Students, as I told you already, coaxial cable, it was widely used in analog telephone networks, and a coaxial cable, when used in analog telephone networks, it was capable of carrying 10,000 voice channels. Huge. From an analog perspective, that was pretty big back then. And then we started using this in the digital telephone networks as well. And in that particular case, our digital telephone network applications, it was able to carry data rates of up to 600 megabits per second. So students, coax cable in telephone cables, it is largely being replaced by fiber optic cables because of the speeds that are available by making this information travel in the form of light in fiber optic cables.